friends. Hope you all are doing well. Welcome to AS Tutor Point. Today we'll go through the science subject that in it matter in our surroundings and is matter around us are pure. So from tiny particles to plasma, everything you need to know about states of matter, mixtures, solutions and separate techniques. So, what we'll cover in this session is particles of matter, what matter is made of, and how particles behave, states and change of states, that is solid, liquid, gas, and how they interconvert, evaporation and cooling, why sweat cools you and clothes dry faster, pure substance and mixture, that is elements, compound, solutions and colloids, separate techniques, how we purify and separate mixed matter. So we'll go through particles of matter, that is everything around you is matter. Anything that has mass and occupies space or has volume is called matter. Air, water, stones, even a drop of dew. Step 1, add salt. Salt is placed on top of water in a beaker. Step 2, stir it. Particles of salt get into the spaces between the particles of water. And the step 3 is dissolve. Salt spreads evenly, proving matter is made up of tiny particles. There are 3 key characteristics of particles. Extremely small, a crystal of potassium permanganate colors 1000 liters of water. Particles must be smaller than we can imagine. Second is continuously moving. Particles have kinetic energy. This is why an agarbatti's smell spread across a room. This is called diffusion. Attract each other. A force attraction holds particles together, strongest in solid, weakest in gases. So, solid, liquid and gas at a glance. Solid, definite shape and volume, strong force of attraction, particles closely packed, very low compressibility, negligible diffusion. In liquid, no fixed shape, fixed volume, intermediate attraction force. Particles can slip past each other. Slow compressibility. Diffuses faster than solids. In gas, no mixed shape or volume, negligible attraction force. Particles move randomly fast, highly compressible, diffuses very quickly. So, interconversion of states of matter, that is change of state happens by varying temperature and pressure. Nothing new is created, only rearranged. Solid to liquid, that is fusion, that is melting, while liquid to solid is solidification. Liquids to gas is vaporization, while gas to liquid is condensation. So sublimation, solid equals gas directly. Example, camphor, naphthalene, ammonium chloride or dry ice. So temperature, pressure and latent heat. Increasing temperature, increasing kinetic energy of particles, solid from liquid from gas. Example, ice melts, water boils. Increasing pressure forces particles closer together. Gas can be liquefied by compressing and cooling. Example, CO2, that is carbon dioxide, dry ice at 1 temperature, 1 atmosphere low temperature. Kelvin to Celsius, that is K equals to Celsius plus 273, that is a normal atmospheric pressure. Latent heat, hidden heat energy used to overcome force of attraction between particles without changing temperature. Latent heat of fusion. Heat energy needed to change 1 kg of solid to liquid has its melting point. No temperature change. Latent heat of vaporization. Heat energy needed to change 1 kg of liquid to gas has its boiling point. No temperature change. So vaporization, a surface phenomena. Particles at the liquid surface gain enough energy to escape even into vapor, even below the boiling point. Temperature. Higher temperature, more particles get enough kinetic energy to escape, faster evaporation. Surface area. Larger surface area exposes more particles to the surface, increases the rate of evaporation. Wind speed, that is, moving air carries away water vapor, decreasing vapor concentration near the surface. Humidity, that is, higher humidity means more water vapor already in air, slows down vaporization. Why does vaporization cool you down? Vaporization absorbs latent heat from its surrounding, which lowers the temperature and creates a cooling effect. First, we sweat in summer. Sweat absorbs body heat as it evaporates, keeping our body cool and comfortable. Second is cotton clothes in summer. Cotton absorbs sweat well and exposes it to a large surface area for quick, easy evaporation. Third is water cools in an earthen pot, matka. What is this? So water seeps through pores and evaporates from the outer surface, absorbing heat from the water inside. Acetone feels cold on skin. A highly volatile liquid evaporates almost instantly, draining latent heat rapidly from your palm. Beyond solid, liquid, and gas, modern science recognizes 5 states of matter: plasma and Bose-Einstein condensate join the familiar three. Plasma, a super energetic, super excited gas of ionized particles. The fluorescent tube and neon sign both contain plasma, a mixture of ions and electrons that glows when charged. Also found inside stars, including our sun, which glow due to plasma at very high temperature. Bose-Einstein condensate, predicted in 1920 by Satyendra Nath Bose and Albert Einstein, formed by cooling a gas of extremely low density to super low temperatures. First achieved in 2001 by Eric Cornell, Wolfgang Ketterl, and Carl Wieman, who won the Nobel Prize in Physics for it. Classification of matter. So, matter is classified in two parts: pure substance and mixture. And in that pure substance, elements and compounds, and further divided in mixture, homogeneous and heterogeneous. So, in pure substance, elements are divided in first part, that is cannot be broken into simpler substances. Example, copper, oxygen, iron. And second is the compound, two plus elements combined in fixed proportion. Example, water and salt. So subdivided mixture is homogeneous and heterogeneous. So uniform composition throughout, sugar in water, alcohol in water. And in heterogeneous, non-uniform composition, sand and salt, oil in water. Solutions versus suspensions versus colloidals. So, three types of mixture distinguished mainly by particle size. Solution is less than 1 nanometer, homogeneous particle, invisible, does not scatter light, stable, never settles. Example, salt, sugar in water. Colloid, is 1 nanometer to 1000 nanometer, looks homogeneous but is heterogeneous, shows the Tyndall effect, particles don't settle. Milk, ink, shaving cream. Suspension greater than 1000 nanometer, heterogeneous, particle visible to naked eyes, scattered light, particles settle over time. Mud, sand in water. So the next is expressing concentration of a solution. Concentration is equal to amount of solute in a given amount of solution or solvent. So mass by mass percentage. Mass percentage of solution is equal to mass of solute divided mass of solution multiplied by 100. Mass of solution equals to mass of solute plus mass of solvent. Mass of volume, mass by volume percentage. Mass percentage of solution is equal to mass of solute divided volume of solution into 100, used often for liquid solutes measured by volume. So it's a real example given worked example. A solution contains 40 gram of common salt in 320 gram of water. Find the concentration in terms of mass by mass percentage. So mass of solution is 40 plus 320 equals to 360 gram. Mass percentage is 40 divided by 360 into 100, that is 11.1%. So how do we separate mixtures? Different physical techniques are used depending on the properties of the components in a mixture. So evaporization recovers a dissolved solid from a solution. Distillation separates miscible liquids with different boiling points. Fractional distillation separates miscible liquids whose boiling points are close. Separating funnel separates immiscible liquids using density difference. Sublimation separates sublimate solid from a non-sublimate one. Chromatography separates components of a mixture that dissolve differently. Centrifugation denser particles forced to the bottom by spinning. Crystallization obtains pure solid crystals from a solution, removing soluble insoluble impurities. So techniques in everyday life. Centrifugal fugation, that is denser particles are forced to the bottom while spinning at a high speed. Lighter ones stay at the top. Diagnostic labs, blood and urine tests. Diaries separating cream from milk. Washing machines spinning water from clothes. And second is chromatography, that chroma color separates solutes that dissolve in the same solvent but travel at different rates. Separating colors pigments in a dye. Separating natural colors from blood. Detecting drugs from urine samples. So, physical change versus chemical change. So, physical change is change in physical properties, shape, state, size, with no new substance formed, reversible. Melting of wax ice, cutting of trees, dissolving salt in water, boiling of water of steam. Chemical change, a new substance with new properties is formed and original substance cannot be easily recovered. Burning of a candle, rusting of iron, burning of magnesium, digestion of food. So last we'll go through the key takeaways, that is recap of matter around us. What we did in this session is matter is made up of a tiny ever moving particles that attract each other. Solid, liquid, gases interconvert via changing temperature and pressure. Evaporation is surface phenomena that causing cooling. Pure substances, that is and elements plus compounds. Mixtures can be homogeneous or heterogeneous. Solutions, colloid and suspensions differ mainly by particle size. Physical separation techniques purify mixtures without new substance forming. So this is it from today's session. Hope you have learned something new and hope we will learn the next topic in the next session. So please like, share and subscribe and press the bell icon to never miss an update. Till then, keep learning and keep growing. Thanks for watching.